a 10-digit system. It's from 0 to 9. Once we get to 9, we cannot go any further. We want to go further. We want to go to 10, but 10 does not exist. So because 10 does not exist, we need to revert to 0 and add a 1 at the beginning so that it says we went through this system once. Now we go on and we go on to 19, and 19 is the end of the number system again. Then what do? We go back again. We say, okay, we revert back to 0, and now we went through the number system twice already. So you can see that the number 10 and the number 20 and the number 15 and the number 16 and the number 19 does not exist. It does not exist. Okay, great. So guys, that's the way it works. Now, what we do now, so when we get here, and you see now, I've got 9 and I have 1 extra, then it reverts to 0 with a 1 at the beginning. When I get to 99 and I've got 1 extra, both places reverts to 0, and I've got 1 at the beginning. Same with 999, all 3 places reverts to 0, and I've got 1 at the beginning. Okay, and that basically is the principles of our number system. And if you understand that, then you will understand the binary system, which is a 2-digit system, but basically it works exactly the same. There's the binary system, 2-digit system, 0 and 1. Once you get to 1, you cannot go further because there is no 2. So what do? In our number system, we would have reverted to 0 and putting a 1 at the end when we got to 9, because there's no 1 to go on. So what do? Then you get to 0, 1. You want to add 1, so you revert to 0. Then you put 1 at the beginning. Then you count the next one is 1, 1. Now I want to go further than 1, 1, but I can't go to 1, 2 because 2 does not exist in the system. So 1, 1 is the end of the system. So when I add 1 to 1, 1, then that reverts to 0. That one would now be 1 plus 1, which can't be 2, so it reverts to 0, and I add a 1 at the beginning. And so it goes on and on and on. 1, 1, 1, and 1, that reverts to 0, that reverts to 0, that reverts to 0, and I add 1 at the beginning. Once you understand that, you understand the whole binary system, or a lot of the binary system at least, not necessarily the whole binary system. People, we are live on the chat box. Please keep those questions coming in. I would love to see some questions. Yeah, so please keep the questions coming in. Are all of you guys still with me? Do you now better understand the binary system? Can everyone still hear me? Am I still loud? Am I still clear? You guys need to please tell me. I don't want sound to drop, so I want you guys to know that stuff is still happening and that you still can hear me. I see there's something coming through of sound good. Okay, so I'm going on. So now we continue. And the next step is now addition. And for all of this, I'm going to explain addition. I'm going to explain our number system first, and then I'm going to explain the binary system. So what do we do in our number system if we want to add 29 and 31? You go to your calculator and you say 29 and 31, and that is the cheat method. So what do? We do adding as we did in school. 9 plus 1 is 10. So we write a 0 and we carry the 1. Then we have 1 plus 2 is 3, plus 3 is 6, which leaves me 6. So 29 plus 31 is 60. Let's go to the next one. 96 plus 9 plus 21. 6 plus 1 is 7. 9 plus 2 is 11. That's 111. 949 plus 11, 9 plus 0, plus 1 is 0, carry 1, 1 plus 4 is 5, plus 1 is 6, 9 plus 0 is 9, is 960. So that is addition in our number system. Now, addition in the binary system works exactly the same way. It works exactly the same way. Let's look at that. Okay, we've got the binary system here, and we're going to add 1, 1 to 0, 1. Okay, now one thing you need to know about the binary system is we cannot pronounce a number as we pronounce it in our number system. We have to pronounce a number as each digit on its own. So that would not be 11, it would be 1, 1. And it would not be 101, but it would be pronounced as 101. So let's add 1, 1 plus 1. 1 plus 1 is 2, but 2 does not exist in our number system. So what we already know, 1 plus 1 is 1, 0. So 1 plus 1, put the 0, carry the 1. Then we have 1 plus 1 is 0, carry the 1. 1 plus 0 is 1. 1, 1 plus 0, 1 is 1, 0, 0. Not 11 plus 1 is 100. Okay. Next step, next one. Can you add that one for me? Can you add that one for me? The question is, I've got 1, 1 plus 1, 0. Is the answer 1, 0, 1, 1, 0, 0, 1, or 21?
Yeah.
Is the answer 1, 0, 1, 1, 0, 0, 1, or 21? Guys, I've got some people going on saying 101, 101, 101. Okay, guys, I've got people saying there's a poll coming up. Okay, cool. You can answer the poll. All of the questions we will post via the poll, and we will ask via the poll. And you can answer via the poll. It's like a multiple choice question. It just gives you a little bit of an idea. But for all of the guys that did not answer via the poll, thank you for doing that as well. Thank you for everyone coming in. I can see that 100% of you say that it is 101, and that means you understand the binary system. You understand that the binary system is a system of 2 digits, and that you cannot go further than those 2 digits. If we do this, 1 plus 0 is 1. 1 plus 1 is 0. Carry the 1. 1 plus 0 plus 0 is 1. So all of you that said 101, great stuff. You can get a 10-minute break a little later on. Okay. Guys, we've got the next question. 101 plus 11. Is that 112, 111, or 1011, or 1000? 112, 111, or 1000? Okay, guys, I see there is people coming through, 112, 111, or 1000. Okay, again, you people are clever out there. Everyone is saying it's 100, 1000, which is wrong. If I present it as 1000, it is 1000. How do we do that? Let's add up 1 plus 1 is 0. Carry the 1. 1 plus 0 is 1, plus 1 is 0. carry the 1, 1 plus 1 is 0, carry the 1, it is 1, 0, 0, 0. Is there anyone that does not understand addition at the moment? Addition in binary? Anyone that wants me to explain again? Guys, this is what the forum is very convenient for. This is what the forum of the classroom is very convenient for. If at any stage you do not understand anything, post it on the forum, and almost 90% of the time, another student will be able to help you. Guys, the reason why I say that, when the answer is 0, the 1 always carries no. When it's a 0 and a 0, what is 0 plus 0? Is 0. But what is 1 plus 0 is 1. 1 plus 1 is 1, 0. So when it's a 1, 0 or a double digit, the 1 carries. So not necessarily when it's 0, but when it's a 1, 0, the 1 carries. Okay. Please explain it for the last time. Yes, by sure. Sure means I can. People, let me just continue on that last thought. If ever you don't understand, go onto the classroom, pop the question in the forum. 90% of the time, other students will be able to help you. The reason for this is twofold. Firstly, or maybe there's multiple reasons. Firstly, you communicate with other students, which is very important for you. Secondly, you might understand because the student might explain it to you in a way that I am maybe not explaining it to you. So it's always nice to hear stuff from different perspectives. And thirdly, the benefit is for the student who's explaining, because there is no better way in learning something than explaining it to someone else. Okay. Guys, if we go again, so in the 2-digit system, 1 is the last digit. Okay. In our number system, in the 10-digit system, 9 is the last digit. So if we have a number 9, and we added any number to that 9, let's say we add 2, how do we add? 9 plus 2 is 11. So we put 1 and we carry the 1. And then we say 1 plus 0 is 1. So we do not say 9 plus 2 is immediately 11. It is actually 9 plus 2 is 1, carry the 1. Okay. So in the binary system, 1, which is the end of the line, it's the second digit, plus 1 equals 1 plus 1 is 10 or 1, 0, but we do not write it immediately. It's 0, and we carry the 1, and then it's 1 plus 0, and that is 1, 0. Okay, so guys, you guys are more happy with that? Do you understand? Are you happy with that now? Can I move on? We're going to move on. So guys, that is addition. Now, if you understand our number system, then you will understand the next one as well. It's subtraction. Let's recap our number system first. If I have 21 and I were to deduct 9, most of us will be able to say that's 12. But it's a way of doing it. 1 minus 9, we cannot do that. Guys, we cannot say 1 minus 9 because we don't want to go into the negative. So what do? We go and borrow from the 2. So we borrow 1 from the 2. The 2 becomes 1, and we borrow 1 from the 2. So now it is 11 minus 9. And 11 minus 9 is 2, and then we have 1 minus 0 is 1. Next number, 96 minus 7. 96, 6 minus 7 we can't, so we borrow from the 9. So the 9 becomes an 8, and it becomes 16 minus 7. 16 minus 7. What is 16 minus 7? 16 minus 7 is 9. 8 minus 0 is 8. 96 minus 7 is 89. Next one. We cannot do this. 2 minus 5, we cannot do this. So we borrow from the 4, it becomes 3. We've got 12 minus 5. 12 minus 5 is 7. 3 minus 6, we cannot, so we need to borrow from the 9. It becomes 13, and the 9 becomes an 8. 13 minus 6 is 7. 8 minus 0 is 8. It's 877. Okay, so hold on to that principle. If you cannot minus, then you borrow from the number before it. Now, at this stage, it's important to say, binary, other than our number system, binary cannot go into negative. Binary cannot go into negative. Okay, so let's go on to the binary system. There's the binary system. 1, 0 minus 1. 1, 0 minus 1. Let me explain this to you. 0 minus 1 we cannot do. So we need to borrow from the previous number. We borrow 1, that becomes 0. 1, 0 minus 1 is 1. 1, 0 minus 1. This side we have 0 minus 0 is 0. 1, 0 minus 1 is 0, 1, or just plain simple 1. Okay. Next up, I've got 1, 1 minus 1. 1 minus 1 is 0. 1 minus 0 is 1. 1, 1 minus 1 equals 1, 0. 1, 0, 1 minus 1, 0. 1, 0, 1 minus 1, 0. Is it 1, 1? Is it 1, 1, 1? Or is it 1? 1, 1, 1, 1, 1, or 1, 0, 0. 1, 1, 1, 1, 1, or 1, 0, 0. I've got a 1, 1, 1. I've got a 1, 1, 1. 0, 1, 1. Sorry, another 1, 1, 1. There's the poll. Is it 1, 1, 1 or 1, 0, 1? Or is it none of the above? Let's look at it. 1, let's start at the right-hand side. 1 minus 0 is 1. 0 minus 1. I cannot. So I need to borrow. I need to borrow. There it goes. That one becomes 0. 1 minus 1 is 0. 1, 0, 1 minus 1, 0 is 0, 1. 1, 0, 1 minus 1, 0 is 1. Okay. We can add that as well. 1, 0. 1 minus 0 is 1. 1 minus 1 is 0. 0 minus 0 is 0. Am I right, guys? Am I making a mistake? Am I making a mistake? It looks like I'm making a mistake because that number there is the same, and it cannot be the same. So what is 101 minus 10? 1 minus 0 is 1. 1 minus 1 is 0. So if I have 1, 0 plus 1, but that would be 1, 1. Okay, guys, something is wrong here. Help me write. Who can help me write? Explain to me, please. Guys, this is why it's so important that you understand. Even if your lecturer gets a mistake, you need to pick up on it. 1, 0 minus 1 is 1. Yes, I'm with you. 1, 0 minus 1 is 1. One, 0, 1 minus 1. No, minus 1, 0. 1 minus 0 is 1. And then 1, 0 minus 1 is 1. Guys, here's where we made the mistake. That is 1, 0. What is 1, 0 minus 1? It's 101. No, it's not 101. Let me explain again. Let me see if I can explain again. Okay, there we go.
0, 1, 1.
So we have 1 minus 0. 1 minus 0 is 1. Now we can't have 0 minus 1. So we need to borrow from that one. So now it becomes 1, 0 minus 1. 1, 0 minus 1. What is 1, 0 minus 1? If you count 1, 0 is the first number, 1 is the second number, 1, 0 is the next number. So 1, 0 minus 1 is 1. And then we have 0 minus 0, and that's 0. So the answer is 1, 1. The answer is 1, 1. And this answer, you do not have to present it as 0, 1, 1. You can simply say it's 1, 1. Because what do we know? If there's a 0 at the beginning, we can throw away the 0 in our number system as well. Okay, guys, so do you understand this? I've still got 9% that says it's 0, 0, 1. I've still got 9% that says it's 0, 0, 1. 8%. Guys, it cannot be 0, 0, 1. If at any stage you get a question like this and you need to deduct it, if there's a minus there, if you go that way, there's a minus there. If you go that way, there's a plus there. So test it for yourself. 1, 1, which is that one, plus 1, 0, which is that one. 1 plus 0 is 1. 1 plus 1 is 0. Carry the 1. 1 plus 0 is 1. So if at any stage you find there's a problem, test it for yourself. Test it for yourself. Will we lose marks if we present the answer as 0, 1, 1 instead of 1, 1? The answer there is no. I cannot say with absolute certainty because I have nothing to do with the exam. ICB is totally independent. But if you present a 0 beforehand, I cannot see that they would deduct any marks, except when you're working on a computerized system and the computer marks it exactly as you input it, then the computer would mark it wrong if you put a 0 beforehand. Because
What would you then suggest I put it like 0, 1, 1? 1,
1, 1, 1, 1. If you're writing by hand, you go in and you write by hand in November or in the beginning of the year. If you write by hand, it's okay to write 0, 1, 1. But if you do it on computer, throw away the 0. Because the computer marks it exact. Your answer needs to be exactly what the pre-set up answer that they input into the computer is. Okay, right. Now we can continue. Does everyone understand addition and subtraction? Everyone understand addition and subtraction? Does the answer your question? Okay, cool. Guys, everyone understand addition and subtraction? Okay, cool. I'm going to continue. If you have a question, then we will have a question and answer session. Keep your questions or post them now, and we will answer your question. Next up, conversion. Conversion. So you are going to get a question in exam. If you get a question on binary, where they're going to say, convert that to binary. Okay, convert 54 to binary. So how do we do that? Well, we know the binary system has 2 digits. Only 2 digits. So what we do is we continuously divide by 2. So our first step would be 54 divided by 2. That gives me 27. Okay. Can you see that 27? It does not have a decimal after it. 54 can be equally divided by 2 as 27. There's no addition, no decimal. So in our third column, we make 3 columns. In our third column, we write a 0. Now we have 27. Again, 27. We divide by 2. 27 divided by 2 is 13,5. 13,5. Can you see that number has a decimal? When there's a decimal, we don't like it. So we write the 1. Now the next step, we throw away the decimal and we say 13 divided by 2. So if there's a decimal, you write the 1, then you throw away the decimal. Then you go ahead and you divide by 2. 13 divided by 2 is 6,5. Again, there's a decimal. So we write the 1. Throw away the decimal, 6 divided by 2 equals 3. No decimal, 0. 3 divided by 2, 1.5, decimal 1. 1 divided by 2, 0,5, decimal 1. Okay, guys, that working is a little bit weird there. But anyway, now, what is the answer now? Those of you that study, that knows this, is the answer now 011011, or is the answer 110110? 110110. In other words, what I'm asking is, do you read from the top bottom, or do you read from the bottom up? 110110, 110110, bottom up, from the bottom up. 110110, bottom up. Guys, bottom up, bottoms up. You are exactly right. You are exactly right. Guys, it is not impossible that you will get a question in the exam where they say to you at the last option, none of the above is correct. Trust yourself. You did the work, you know the work. You know the work. Okay, guys, great stuff. Let's do 27. 27 converted. What's my first step? First step. Anyone, what's the first step? 27 divided by 2. What is 27 divided by 2? 27 divided by 2 is not 1. You're skipping a step. What is 27 divided by 2? Is 13,5. And there's your 1. Okay. Now what's the next step? Next step. Almost, but not quite. Remember, if you're now going to divide, you throw away the comma and it becomes 13 divided by 2. 13 by 2 is how much? 6.5. Again, there's a half, so I write the 1. What's the next step? Guys, you can see this interactive class. You have to participate. Rachel says 6 by 2. That is correct. 6 by 2. 6 by 2 is 3. Write the 0 because there's no decimal. What's the next step? 3 divided by 2. 3 by 2 is how much? 1.5. So what do I write there? 0, 1. 1. Okay, guys, 1. What's the next step? 1 divided by 2 equals 0,5. And that is how much? 1. Okay. Guys, and now, what is the answer? This one is convenient. It doesn't matter if you read it from the bottom or the top, but you know we read from the bottom up. 1, 1, 0, 1, 1. 1, 1, 0, 1, 1. Anyone else who still have a problem with this? Guys, if you if you don't understand yet and you need to ask, please ask. Does everyone understand conversion from a decimal to a binary? A decimal to a binary, yes, yes. I've got a lot of people saying yes, they understand. If you don't understand, please give me a question. Guys, I need questions from you guys. I need guys to tell me what do they still struggle with. When we get to question and answer, we need to know what you're still struggling with. Ruan, yes. If there's a decimal, it will always be a 1. And have you taken note that the decimal will always be 5? We cannot have any other decimal except 5. But once there is a decimal, the number will always be 1. And when it's a full number, it will always be 0. Okay. If everyone is happy with binary with conversion from decimal to binary, I can go on and I can do conversion from binary to decimal. And let's first say, I'm going to explain this again on the hand of our number system. Let's say that number was 101. If I'm talking about 101, then I'm talking about our number system. So let's say that number was 101. Would you agree with me that is 100 plus 0 plus 1? 100 plus 0 plus 1. Okay. Would you agree with me that is 1 times 10 to the power of 2 plus 1 times plus 0 times 10 to the power of 1 plus 1 times 10 to the power of 0. Would you agree that's that? Ten times 10 to the power of 2 is 100 times 1 is 100. 10 to the power of 1 is 10 times 0 is 0. 10 to the power of 0 is 1 times 1. Something to the power of 0 is always 1. Okay. Now, so that is what 1 to the power, that is what I can express that number as. Now, this is the principle for conversion from binary to decimal. We are going to say exactly like we put it out there, we are going to put it out in binary, except where that's a 10, and that's a 10, and that's a 10, we're going to make it a 2 because we're working with a 2-digit system. So this is 1 times 10 to the power of 1 plus 1 times 10 to the power of 0. All of you agree with that? But it's not 10. So if this is binary, then this is to the power of 2. So 1 times 2 to the power of 1 plus 1 times 2 to the power of 0. What is 2 to the power of 1? 2 times 1 plus 2 to the power of 0 is 1 times 1. That's 2 plus 1 equals 3. 1 to the power of, or 1 in binary is 3 in decimal. 1 in binary is 3 in decimal. I want you to take what you've learned now, and as a final thing before we go over to questions and answers, I want you to convert 1, 0, 1 to decimal. 1, 0, 1 to decimal. Convert 1, 0, 1 to decimal.
The poll is there, they can answer.
101 to decimal. First of all, it is going to be something times 2 to the power of something, plus something times 2 to the power of something else, plus something times 2 to the power of 0. How do I know how many powers are used? Can you see there's 3 numbers? I start on the right-hand side, and the one on the right-hand side becomes to the power of 0. Then I've got 1, then I've got 2. So in here, I'm going to use 2 to the power of 2, 2 to the power of 1, and 2 to the power of 0. Another way of recognizing it is there's 3 numbers. So the powers of 2 that I'm going to use is 3 minus 1 is 2. Okay. So I'm going to say 1 times 2 to the power of 2 plus 0 times 2 to the power of 1 plus 1 times 2 to the power of 0. That is 4. That is 0. That is 1. 4 plus 1 equals 5. I've got people saying 5. Yes, I've got people saying 5. I've got a 5 there with a question mark. At the moment, it's okay that you have the question mark. But in the exam, it's not going to be okay. There's no one to say yes or no. You have to trust in yourself. So guys, I am happy that you are saying 5. Those of you that are not saying 5, as we go on to questions and answers. Okay, there's more converted. This is just something that I wanted to explain. Can you see there? There's a subscript 10. There's a subscript 2. If there is a subscript 10, then it means it is a decimal. In other words, to say it is an L number system. So that would be 101,101. If there's a subscript 2, then it is in the binary system. So that would be 101101. Okay. And that takes me to questions and answers, guys. If you've got questions and answers, please ask them. Please ask them. I need to know if you understand. If there's anyone that still wants me to explain something else, something more.
Can they unmute or not?
Hmm?
Can they unmute?
Yeah.
Gerald might have a question.
Gerald might have a question. What is Gerald saying? You're a bit lost. In what sense? Where are you lost, Gerald? Tell me, where are you lost? With what? With addition, with subtraction, with conversion from decimal to binary, or with conversion from binary to decimal? Guys, this is important as well. If you send me an email and you say, I don't understand, you need to be very, very, very specific. Conversion, Gerald, conversion in what direction? From decimal to binary or from binary to decimal? If I explain this quickly to you, if I've got a number 27 and I'm going to convert from decimal to binary, then I am going to do the process where I divide by 2 the whole time. So I'm going to say 27 divided by 2, then I'm going to say 13 divided by 2. 27 divided by 2 is 13 and a half. There's a half, so I'll write 1. 13 divided by 2 is 7 and a half. There's a half, so I'll write 1. 7 divided by 2 is 3 and a half. There's a half, so I'll write 1. 3 divided by 2 is 1 and a half. There's a half, so I write 1. And then 1 divided by 2, again there's a half. So I write 1. So 27 divided by 2 binary is 1, 1. Am I not right?
6,5.
6,5.
13 divided by 2.
Not 7.5, it's 6.5.
Yeah.
Okay. Right. So that should be a 0. Yeah. Okay. Let me do it the whole thing over again. $27 divided by 2, 13 and a half, 13,5, write 1. 13 divided by 2, 6,5, write 1. 6 divided by 2, 3, write 0. 3 divided by 2, 1.5, write 1. 1 divided by 2, 0,5, write 1. Okay, we're still busy with Gerald. Gerald, are you happy with that one? And now you read from the bottom up. You read 11011. Gerald, are you happy with that one? Great. Then the other conversion is from binary to decimal, where we have the number 101. We say there's 3 numbers, so we're going to multiply by 10 to the power of 2, by 2 to the power of 2, 2 to the power of 1 and 2 to the power of 0. So it's going to be 1 times 2 to the power of 2 plus 0 times 2 to the power of 1 plus 1 times 2 to the power of 0. Okay. Are you happy up to that stage? Happy up to that stage? Okay, cool. So it's going to be 1 times 2 to the power of 2 is 4. Plus 0 times 2 to the power of 1 is 2. Plus 1 times 2 to the power of 0, anything to the power of 0 is 1. So it's going to be that. 1 times 4 is 4. 0 times 2, anything times 0 is 0. Plus 1 times 1. Plus 1 times 1 is 1. 4 plus 0 is 4, plus 1 is 5. Happy with that one? Gerald, you happy with that one? You understand conversion now? Okay, cool. Great. There's one other question. Someone had another question?
Comfort. From comfort, there's a question like a long one.
Was it comfort?
9.
There was something else. Okay. When subtracting binary numbers, I struggle and get confused. Is it okay if I convert the binary number to decimal, then subtract? No. Do not, if you're saying subtract binary from each other, do not go near conversion. Do not go near conversion. Okay. I haven't checked that, but I suppose it would work out in some way. But I haven't researched that, so I can't tell you that it will work out. But what I suggest is when they talk about subtraction, keep to subtracting, do not convert at all. So when we have 1, 1 in binary and we deduct 1 from that, basic principles as in decimals accounting. If you have 1 minus 1, what is 1 minus 1? 0. What is 1 minus 0? There's a 0 there. Right? 1 minus 0 is 1. There's your answer. 1, 1 minus 1 is 1, 0. Now, what if I have 1, 0, 0 minus 1, 1? Same principles as in decimals. I cannot deduct the 1 from a 0. It's not possible because I'm not allowed to go into negative. So what I do is I go to borrow from the number before it. But I can't borrow from that number because it's also 0. If you have nothing, you cannot give something to someone else. So I go and borrow by the number before it. So that number borrows to that one, which becomes 1, 0. And then that number borrows to that one, which means it is now 1, 0. And it's 1, 0 minus 1 is 1. And that is 0 minus 1. And that can't be. So you cannot deduct 1, 1 from 1, 0, 0. It's going to give you a negative, and we are not allowed to have negatives. They will not give you an answer like this. Because what I'm saying here is that is now 0. 0 minus 1 is going to give you a negative, and that is not allowed. Let me do another one.
Almost 10, so we might lose power like we will start. It's almost 10. Load shedding.
Yeah, but we'll done now. Thank you for that. Let's say 1, 1 minus 1. We cannot have that 1, no. 1, 0 minus 1. We cannot have a 0 minus 1. So we borrow from the 1. So it's 1, 0 minus 1 is 1. There's a 0 minus a 0 is 0. So 1, 0 minus 1 is 0, 1. Comfort, do you understand better now? 0, 1. Okay. Great stuff. Guys, it is now 10 o'clock, so we're probably going to have a 10 now. So we will take a break until 10 past. Right, guys, let's take a break until 10 past, and then we come back and we do the next one, which I think is.
Yeah. Dat kan niet meer. 5 minuten. 5 minuten. Why did you put it on again? Stage 5, nee. Stage 5 gekomen.
Stage 5.
Aan 10 jaar af, ja.